Hi class, last prelim we've talked about hydrology, its importance and its difference from hydraulics. We've talked about watersheds, reservoirs, dams. We discussed about atmosphere, the main source of energy, the sun, and these two are the main reasons why we have different climate and weather. Bale, the energy from the sun is the primary mover of the atmosphere by giving Earth varying pressures and temperature. And this movement of the atmosphere makes possible for the change of phase or form of the air. So that is what we call yung hydrologic or water cycle. So water changes state from gas to liquid, liquid to gas, solid to liquid if you're in low temperature regions through snow or ice. The main phase of a hydrologic cycle that has great impact and importance to us is the precipitation. Dahil dito nanggagaling, ito yung source of water natin that we use in a daily basis. That's why it is very important for us to gather data. We measure it, kina-quantify natin ang water, we study, we store the data for several years. That is, of course, to predict its movement and occurrence sa future. So, for this midterm, we'll talk about precipitation. So, what is precipitation? The term precipitation denotes all form of water that reach the Earth's atmosphere. So, usual forms of uh, precipitation is rainfall, snow, hail, frost, etc. So how do we have precipitation? Number one, the atmosphere must have enough moisture. So moisture in the form of clouds. Number two, there must be sufficient nuclei present to aid the condensation. These nuclei are similar doon sa mga salt particles that are used sa cloud seeding. Then next, number three, weather conditions must be good for condensation to take place. So good weather conditions for precipitation is of course not warm weather. It is best na yung ano to? Cool weather kumbaga. Kasi kapag warm ang weather, mainit, that pushes clouds upward. So hindi pa babagsak ang rain. Excuse me. Number four, the products of condensation must reach the Earth's surface. So there are times na nagko-condense na yung tubig, pero dahil mainit pa ang panahon, while it travels downward, nag-evaporate din siya at the same time. So if it completely evaporates before it reaches the ground, it cannot be called precipitation. So the water droplets must reach yung Earth's surface. So all in all these elements, yung the weather conditions, wind speed, nuclei, the temperature, humidity, and pressure, they all act and affect condensation or precipitation. So these are the forms of precipitation. This topic, medyo pasadahan lang natin, na-report na to or na-discuss na to before. So pasadahan lang natin. So forms of precipitation, we have rain, snow, drizzle, glaze or freezing rain, sleet, and hail. So of course, rain kapag in water form yung precipitation. And then it has types based on its intensity and dun sa size niya in mm. Then snow, of course, ito ay in form of ice. So malalamig na lugar siya. Drizzle is a sprinkle of rain lang. So maliliit yung water droplets kaya hindi siya ma-classify as rain. Dahil mas maliliit yung dimension ng droplets niya. Glaze or freezing rain, so this is precipitation na first ay siya when it falls down, makakamit siya ng warm mass. So magme-melt siya into water. Pero when it touches the ground, dahil malamig pa, masyado namang malamig yung na-touch niyang surface, nagfo-freeze ulit siya. Nagpo-form into ice pa din siya. So, difference dun sa sleet, yung sleet, mag-start din siya into ice form sa atmosphere, magpo-fall down siya, may mamimit siyang warm mass pero manipis lang. So, pagbaba niya, pag lampas niya dun sa warm mass, magfi-freeze ulit siya dahil malamig ang surface ng ground, and before it touches the ground, naging ice ulit siya, or in form of ice or sleet siya. So, yung difference niya dun sa freezing rain or glaze, yung freezing rain, before it touches the ground, water na siya. Kapag na-touch niya yung ground, dun siya mag-freeze ulit. But yung sleet, before it touches the ground, nag-froze na siya ulit until it touches na nga yung ground. And then hail, this is a shower of lumps of ice. So, malalaking parang batong ice siya. So, these forms of precipitation is best described with the video na in-attach ko. So, meron siyang animations. So, mas maganda. Next, types of precipitation. So, precipitation, they happen because of varying reasons. So, number one, convective precipitation. This is caused by convection. And then yung orographic, it is caused by the presence of mountain or mga high high level grounds. The number three, cyclonic or frontal precipitation. This is due to yung pag-meet ng dalawang front masses or air masses, warm mass or cold mass of air. So, meron tayong warm front and then may cold front. Then number four, artificially induced rain. So, nagkakaroon tayo ng rain artificially by cloud seeding. So, again, these types of precipitation are discussed dito sa na-attach kong video. So, maganda din yung discussion niya. Next, weather systems for precipitation. For the formation of clouds and subsequent precipitation, it is necessary that the moist air masses cool to form condensation. So, these are the weather systems associated sa precipitation. Meron tayong front, merong mga cyclone. Cyclone are categorized into extratropical cyclone and then tropical cyclone. And then lastly, we have anticyclones. So, I also attach video.
Today, we're talking about fronts in
Maganda din
aviation.
yung discussion nila. So, ito yung ginamit ko. In-attach ko siya. Mas maganda yung discussion niya. The next, classification of tropical cyclones by Pag-asa. So, it is here in the Philippines. So, this classification ay based dun sa wind speed niya, sa intensity ng storm. So, first is the tropical depression, tropical storm, severe tropical storm, then typhoon, super typhoon. So, of course, pinaka maliit pa or less intense yung tropical depression, and super malakas is yung ito, super typhoon. The measurement and data analysis of precipitation. We have on the slide mga different instruments in measuring and accumulating data ng mga precipitation. So these are rain gauges. They are placed in areas of study, actually all over the Philippines, syempre. So we have non-recording gauges. Example is itong number 1. So, kailangan pang mag-read ng tao dito para makuha yung measurement. So, yung mga recording rain gauges, itong example A, B, and C, meron silang sensors, kaya na-detect and nare-record na nila yung data. So, ina-attach yung mga recordings nila sa isang data system para ma-save ang mga gathered data nila. Telemetering rain gauges and radar measurement of rainfall. Itong dalawa, are, ano ba to, um, they are used sa mga hard to reach places, or this one, itong number 3, used sa mga hard to reach places kasi solar powered siya, and then yung data niya are gathered automatically, and then pinapass na lang niya through satellite yung mga datang nagagather niya. And then itong number 4, these are used pang long distance yung na-measure niya. So, malaking area ang sasakop ng data gathering niya. So, ring gauge network, an area of study, syempre nilalagyan or dinedeployan natin ng mga ring gauge stations. Hindi lang isa, syempre, madami yon, and meron tayong computation for that. So, each ring gauge network, lahat ng data na re-record nila, they should be consistent and of course correct. Kaya kapag may isang, syempre, hindi maiiwasan, there are times na may masisirang isang instrument, so nagkakaroon ng missing data. So, meron din tayong estimation to cover that, kumbaga, error due to missing data. Number 3, test for consistency of record. Ring gauges per station, ayun nga, they should be always precise, accurate, and consistent para maging tama lagi yung nare-read. Kasi importante yung mga data nire-record nila. So, they are also tested for consistency. Kasi, syempre, in an area, pwedeng magbago ang precipitation sa area na yun based sa change din nung pwedeng may change sa topography, change sa ecology ng area. We will discuss more later. And then ito, mass curve of rainfall. So each station, ginagawan siya ng mass curve or hyetograph. Doon ini-interpret yung mga datang nakukuha niya. Point fall rainfall. This is yung data gathered ng isang station lang. Then mean precipitation, of course, meron tayong observation area na merong maraming rain gauges. So these rain gauges, kinukuhaan ng data and ina-add up to get yung average precipitation depth na nakukuha nila. Then, number 7, depth area duration relation. So, these are all yung area related na. Items 6 to 7 are about estimating yung total rainfall in an area from a network of rain gauges. And then items 8 to 10, frequency of point rainfall, plotting position, probable maximum precipitation, they are all about forecasting rainfall from the data that you have gathered from past na precipitation occurrence. So yung item 1 to 5, they are measurements for one rain gauge station lang. And kasi kada rain gauge, chine-check and dinedecipher pa for correctness. So, let's first talk about yung rain gauge network. Ito yung kumbaga reference kung ilang rain gauge ang kailangan mo in an area. So for ideal condition, one station ang kailangan mo for 600 to 900 square kilometers. So kung meron kang 1,800 square kilometers, you need for ideal condition one rain gauge station. So for acceptable condition, pwede mong laki-lakihan. So in mountainous regions, so ito naman yung reference kung ilang rain gauge ang kailangan mo per square meter given. So we also have this formula to get the number of stations required in a place kapag given yung yung given meron kang degree of error, meron kang CV. So for example, 2.1, a catchment has 6 rain gauge stations. In a year, the annual rainfall recorded by each station are as follows. So for 10% error in estimation of the mean rainfall, calculate the optimum number of stations in the catchment. So preliminary, meron siyang 6 rain gauge stations daw. But the problem wants to check if enough na yung 6 rain gauge stations na yun, if it wants a 10% error only. So we can use this formula. N is equal to CV over E squared, quantity squared. So M natin, of course, we have 6 stations. So 6 yung M natin. Average ng precipitation is, add mo lang to, divided by 6. And then get the standard deviation using this formula. We're using yung Caltech sa mga calculators natin. Merong formula doon or merong mode doon where you can get yung standard deviation of a given data. Then percentage error natin, of course, is 10. So with this data, we can get CV. So 100 times yung standard deviation divided by yung average ng rainfall. Then we can substitute that doon sa formula N. So N, we get 8.7. So round up mo, syempre, we get 9 stations. The catchment needs at least 9 stations para 10% error lang siya. So estimation of missing data. So, kunwari, meron kang 6 ring gauge stations. Suddenly, nag-broke down yung isa. So, hindi siya makapag-record ng data for 1 year or ganyan. So, you have to estimate yung missing data using yung recorded ng iba pang natirang ring gauge station. So, meron siyang limit yung nilagay dito. If the normal annual precipitation at various stations, yung mga natirang station, is about 10% of the normal annual precipitation ng missing data, then you can use this simple arithmetic average na formula. Pero if yung normal annual precipitation ng mga natirang station are greater than 10% nung normal annual nung missing station, you need to use this formula. So let's use itong example 2.2. The normal annual rainfall for stations A, B, C, D are 80.97, 67.59, 76.28, and 92.01 centimeter respectively. Pero in 1985, yung Station D ay nasira. So, yung tatlong stations na lang ang gumana at nag-record ng mga precipitation. So, ito yung na-record nila, 91.11, 72.23, and 79.89 centimeter. So, since may missing data si rain gauge D, estimate natin yung rainfall niya for that missing data that year. So, first, kailangan mong i-check if anong formula ang gagamitin mo, itong or ito. So, how do we do that? Kailangan mong kunin yung difference nung normal, yung normal annual precipitation ng missing data nung D minus yung lowest record doon sa kasama yung station, and that is 67.59. So, yun yung maximum difference, 24.42. And if ito, i-divide mo dun sa 92.01, which is the normal annual precipitation ng missing X, ng missing data na station D, you will get 26.54%. And this is greater than 10%, greater siya sa 10%, so hindi mo magagamit to. Pag less than 10% ito, like 9% na nakuha mo dito, ito na yung gagamitin natin. But since greater than 10 siya, ito yung gagamitin natin. So using this formula, substitute lang natin yung mga given. Precipitation ni A for that year, 91.11 over yung data niya, yung normal data niya, 80.97, and then for station B, 72 divided by yung normal depth niya, 76.28. Ay, ito pala, sa C pala yun, 67.59. And then for station C, yung measurement niya for that year na 79.89, divide mo dun sa normal depth niya na 76.28. Then this quantity yung multiply dun sa normal depth ng missing data, missing station over 3. 3 dahil tatlo yung remaining rain gauge station. So doing the operation, you get the estimated precipitation depth ni station D na 99.49 cm. So ito kasama ng tatlo. Estimated precipitation depth ni station D for year 1985. So next, of course, yung mga datang na re-record nga ng rain gauges natin, we need to test for consistency. Kasi nga, pwedeng may mangyaring changes sa isang area, and those changes can affect yung precipitation sa place. Ibig sabihin nun, mag-iiba yung mare-record na data ng rain gauge mo. So what are these changes? Number 1, shifting of rain gauge station to a new location. An area, meron na siyang kung walang mag-change sa area, constant or may range constant ang kanyang precipitation. Example, sa mga rainforest, madalas ang rain doon because of the characteristics ng rainforest. Madalas ang rain. So, kapag bigla ang rain gauge doon, nag-iba yung precipitation, kunwari bumaba, ibig sabihin baka may nangyari sa rainforest. Pwedeng may nakalbong part siya, kaya nabawasan ang precipitation niya. So, similar to this number 1, kapag change mo naman ang location ng rain gauge mo from a humid place to a dry place, so mag-iiba din ang i-record niya, magiging inconsistent siya. Number 2, yung neighborhood ng station, nagkaroon ng change. For example, ayun nga, rainforest siya. So, madalas ang precipitation biglang bumaba, ibig sabihin baka may nakalbo siyang part. So, may nagbago doon sa neighborhood, sa area ng rain gauge natin. Number 3, may change in the ecosystem due to calamities such as forest fires, landslides, or these calamities, they can change yung ecosystem, di ba? They can kill several wildlife, even yung vegetation in place. So these calamities can cause change in precipitation then. And then number 4, occurrence of observational error from a certain date. So, kumbaga, people error to. There is observation error from a certain date. Wrong record of data. So, due to these inconsistencies or errors, we use this method naman para ma-check. And we can make estimations or corrections para maging para matrace natin yung bagong trend ng precipitation dun sa area. So how do we do this? Let's see this example 2.3 wherein meron tayong data. This is data from 1950 hanggang 1979. So it is a span of 30 years. So meron siyang rain gauge, annual rainfall. May data siya ng annual rainfall ng Station M na rain gauge. And then meron din siyang annual rainfall data of 10 group of neighboring stations. So, itong Station M, meron siguro siyang sudden change, may na-observe na sudden change sa kanya, kaya i-test siya for consistency. How do we do that? We compare it to the neighboring rain gauges sa kanya. So, i-average mo to yon and ito yung makukuha nating data, itong third column. So, I've attached, ni-record ko ito. This is a video recording kung paano nakuha or paano masosolution yung adjustment, paano i-adjust ang mga inconsistent na record. Kumbaga, meron ng trend of precipitation yung area, pero nag-change siya. So, you have to adjust that old trend to the present trend. Kasi hindi na siya consistent, hindi mo magagamit yun. Kailangan i-update mo siya kung ano ang present situation ng area mo. That's why we do this adjustment. Please watch the video na lang kasi naggamit siya ng ginamitan ko na lang siya ng Excel. At saka with data naman kasi since large data ito, they are used or they are solved or observed using Excel and of course yung charts ng Excel. So next, mass curve of rainfall or hyetograph. So mass curve of rainfall is a plot of the accumulated precipitation against time. So kung makikita nyo, this is the days, day 1, day 2, day 3. So arrange chronological versus yung accumulated precipitation. So, ibig sabihin, kung sa day 1, meron ka ng how much? Tentatively, may 5 cm rainfall ka. And then, tuloy-tuloy pa din yung ulan. So, nag-day 2 na, umuulan pa rin, na-store na yung precipitation. Nag-accumulate na, tumaas na yung precipitation, napunta na siya, tentatively, say, kunwari 10. Nasa 10 cm na yung precipitation. And then, day 3, so, as you can see, flat yung slope natin dito, hindi gaano tumaas yung depth ng precipitation. But suddenly, on day 4, lumakas ulit yung ulan. Tumaas ulit yung precipitation depth na, say, 14. So, that's a mass curve of rainfall. It is the duration, yung duration ng, ng storm mo, yung rainfall mo, versus accumulated precipitation. And then, hyetograph of a storm. This is a graph naman showing yung duration ng storm versus intensity ng rainfall. So, intensity of rainfall, this is yung increment per time. Ayun, increment ng rainfall over time. We will have an example of this dito sa next topics. So, let's discuss first yung point fall rainfall. Point fall rainfall, also known as station rainfall. So, this is yung rainfall data in one station only. So, it's called point fall rainfall. It refers to the rainfall data of a station. Graphically, these data are represented as plots of magnitude versus chronological time in the form of a bar diagram, like this one. Such a plot, however, is not convenient for discerning a trend in the rainfall, as there will be no considerable variation in the rainfall values, leading to rapid changes in the plot. So, ito yung rainfall for one station. Kung i-bar graph mo siya, makikita nyo, very inconsistent, varying yung trend niya. Actually, halos wala kang trend na makikita kung ganyan siya. So that's why we use moving average technique. We use that to smoothen yung data, yung series of data para somehow may makita tayong trend. So we need to see a trend to be able to forecast ang precipitation dun sa area. So we can show this by this example 2.4. So we have this data, a rainfall record for station M for a period of 950 to 1979. This is the example given sa 2.3, yung kanina lang. So, so pinapakuha ng problem yung years, identify those years in which the annual rainfall is less than 20% of the mean and yung more than the mean. And then plot the 3-year moving mean of the annual rainfall time series. So, So we have this rainfall data na nakuha dun sa example 2.3. So kung iba-bar graph mo siya, very magulo siya. So let's do yung moving average technique. That is yung 3-year moving mean. So I've recorded a video again. This one.
Now,
This
let's
video
face example.
shows paano gawin. This video shows paano gawin yung moving average technique. So please watch the video na lang to solve yung problem. So number 6, mean precipitation over an area. Now, we are done discussing about yung rainfall in one rain gauge station. Now, next move it to the next level wherein kukunin na natin yung total precipitation over an area. Kasi in an observation area, kunwari in a catchment, hindi lang kasi isang rain gauge ang ginagamit. So, madami yan. So, kagaya dun sa example kanina, it needs 9 stations. So, each station, pwede din, actually, lagi talagang iba-iba yung nare-record nila. Usually, iba-iba. So, paano mo kukunin yung average? We have 3 methods to get the average ng mga rain gauges mo sa isang catchment mo. So, first is arithmetical mean method. This is just the normal average wherein i-add up mo lang yung mga recorded precipitation ng mga stations mo divided by the number of stations. This method is not hindi siya precise. Oh no, ano ko. Very precise yung first method. Ang usual method used is this Thyssen method. Then the other method is isohyetal method. So for example, dito sa naku, So, ayun, using yung Excel, may nakuha tayong formula. This is the relationship between yung precipitation depth versus yung period. This relationship is logarithmic. So, ito ang formula na gagamitin natin to answer yung hinihingi ng problem. So, ano daw ang rainfall depth for a period of 10 years? So, period is yung T. So, substituting T, makukuha na natin yung depth precipitation. Equivalent sa kanya. And then for a period of 50, substitute lang yung 50 sa equation. Makukuha mo yung corresponding depth for that period na 50 years. Then, next, kukunin naman yung probability na mangyayari yung 100 cm na rainfall. So, since ang equation natin is just yung precipitation depth versus yung period, wala yung probability doon, pero we have the formula for probability na P is equal to 1 over T. So, we can just first get yung corresponding period nung 100 cm rainfall, then substitute yung nakuhang period na yon doon sa formula ng probability. So, makukuha na natin yung corresponding probability. So, let's do that. So, let's use this equation. Substitute natin yung 100 cm na pinapa-evaluate. So, 100 cm is equal to 29.326 natural logarithm ng t, which is our unknown, plus 72.024. So, doing the operation, we get t is equal to 2.596 years. Ito yung period niya. And then, yung probability of exceedance niya, we just substitute yung t na to sa formula na to. We get na yung probability equal to 2.385. Next, for letter C, what is the precipitation depth? Okay, yung precipitation depth with 75% probable annual rainfall. So, this 75% is yung probability. Probability na annual rainfall at station A. So, substitute mo lang itong P na to, value ng P. So, ito yung formula to get period. Ito. So, substitute mo lang yung probability in decimal form. So, that is 0.75 dito. Then, you will get na yung corresponding period. So, period is 1.333 years. Then, substitute mo yung yung period na yun, yung T dito sa equation natin ito. Then you will get yung corresponding precipitation depth for that period na 1.33 years. So you get yung precipitation depth na 80.4 centimeters. Next is maximum intensity, depth, duration, frequency relationship. So, silang lahat mayroong effect sa isa't isa. So, we put them on graph to show their relationship. So, figure 22.20, this is the maximum intensity versus return period versus duration curves. So, along its x-axis is yung return period, ito yung t, versus yung maximum intensity. Next, this figure shows naman yung relationship between duration ng storm or ng rainfall versus yung maximum intensity. Then next figure, it shows yung duration versus maximum depth of rainfall. Isopluvial lines are lines that connect points of equal rainfall depth within a given time period. These lines are used to represent the spatial distribution of rainfall over a specific duration such as daily, monthly, or yearly rainfall amounts. So yung isopluvial, this is it connects yung mga areas with same depth of rainfall. Yung isohydral lines kanina, they connect points with equal rainfall intensity. Ito, rainfall depth. Kaya it's called yung spatial distribution. These lines represent nga yung spatial distribution ng rainfall. So these isopluvial lines are particularly useful for analyzing and assessing the overall water availability and runoff potential in a region, which is crucial for construction professionals and civil engineers involved in drainage design and stormwater management. So let's have an example 2.11. So we have this data. The mass curve of rainfall in a storm of total duration of 270 minutes is given below. So, ito yung data natin ng storm, 270 minutes ang duration niya. So, every 30 minutes, given yung cumulative rainfall depth. So, 30 minutes, meron kang depth na 6 mm. The next 30 minutes, that is a total of 1 hour or 60 minutes, meron ka ng total of rainfall depth na 18 mm. So, and so on. So, letter A, let's draw the graph of the storm at 30 minutes time step. Plot the maximum intensity duration curve, and then plot the maximum depth versus duration curve of the storm. So, I've recorded paano isolve yung problem using Excel on the next slide.